All right, today's aim is let's analyze transformations that produce congruent and similar figures. All right, so if you remember, transformations that produce congruent figures are rigid motions or isometric transformations. All right, so those are rotations, translations, and reflections. And then when the figures are similar, that's going to be a dilation, where we have a scale factor involved. All right, so lesson 3, types of transformations. 3.1, what is a dilation? Point B was transformed using the coordinate rule. X comma y goes to 3x, 3y. So we're multiplying the x coordinate by 3 and the y coordinate by 3. Add these auxiliary points and lines to create two right triangles. Label the original P. Plot, when they say the original triangle, they mean label the triangle with a P in the middle. Plot points M as 2, 0 and N 6, 0. Okay, so I'm going to do those in purple pen so they really stand out. All right, so M is 2, 0, so that'll be point right there, that's M. And then N is 6, 0. Right, that'll be N. So it looks like we're going to make triangle PMB. I think they mean to say MNB. Okay, maybe not. I'm just going to follow the instructions. Draw line segments P, B prime. Oh, I'm sorry. Label the origin P. I misread that. So they're talking about right here. They want that to be P. All right, now that makes a little more sense. All right, so draw segments P, B prime. So that'll be from, I don't want to do this in purple pen. This will just be in pencil. MB, so MB would be from M to B right here. That I will do in purple. NB prime, this I will remain just in pencil. All right, so here we can see that we've got our two right triangles. So I'm gonna really highlight this little one by using this purple ink here. All right, so we see that we've got this smaller purple triangle and this larger right triangle. All right, how do triangles PMB and PNB compare? How do you know? Okay, so, well, one thing I know is that we have two right triangles here, and they even tell us that they're two right triangles, but I can see that this is a right angle, and this is a right angle. I also know that angle P is shared with the two triangles, so it's reflexive. So because these two triangles have two pairs of corresponding congruent angles, I can say that triangle PMB is similar to triangle PNB prime by AA similarity. Remember that because a triangle adds up to 180 degrees, if I know these two angles right here, there's only one option for this angle. Same with the larger triangle. If I know this angle B prime has to be the same measure as B. There's only one option for each of them. So they have all the same corresponding congruent angles. They must be similar by AA similarity. What must be true about the ratio PB prime? So as you can see, those line segments they're talking about are on a diagonal. So they're going to be rather difficult to count just by reading them, right? If we remember from last lesson, we made right triangles and used the Pythagorean theorem to find this missing side. However, we know from what was given to us in the beginning that x has been multiplied by 3 and y has been multiplied by 3. I also see that right here, my center of dilation is the origin. So I know that what happened here was a dilation of scale factor 3, and it was centered at the origin. So what must be true about this ratio, PB to PB prime? Well, if PB is 1 unit, then that means PB prime will be 3 units because we multiply the original by 3 to get the new one. So that must be equivalent to that original ratio. All right, that's all for 3.1.